The global digital economy relies on a single geological formation in Spruce Pine, North Carolina. This site produces over 85% of the world's high-purity quartz. This material is essential for manufacturing the crucibles used to grow monocrystalline silicon ingots. Global demand for semiconductor-grade high-purity quartz has risen from 22,000 metric tons in 2018 to an estimated 36,500 metric tons in 2024. This growth is driven by massive expansions in 300mm wafer fabrication. As shown on the chart, global demand surpassed Spruce Pine's standalone capacity in 2021. This structural deficit is projected to reach 5,000 metric tons by 2026. The industry now relies on dwindling stockpiles, synthetic alternatives, or lower-grade blending to bridge the gap. The bottleneck is not a matter of mining volume, but of atomic-level purity. Advanced node silicon manufacturing requires quartz with total impurities below 15 parts per billion. Spruce pine quartz exhibits a total impurity profile of just 10.4 parts per billion. Alternative deposits in Russia and Norway exceed this critical 15 parts per billion threshold. They contain elevated levels of aluminum and iron. At temperatures exceeding 1400 degrees Celsius, these impurities migrate into the silicon ingot, ruining its crystalline structure. Refining lower-grade quartz from deposits like Donghai, China, is not a viable short-term solution. The chemical processing required increases costs by 300 to 400%. It also generates substantial hazardous waste, limiting rapid scaling. This supply constraint has triggered extreme procurement latency. Average lead times for high-purity quartz crucibles have escalated from 12 weeks in 2018 to 52 weeks in 2024. The spot market price index has nearly tripled over the same period. Yet, this bottleneck exhibits extreme economic asymmetry. Quartz crucibles represent less than 2% of total wafer manufacturing costs. Because a crucible shortage halts 100% of silicon production, buyers are highly price inelastic. This vulnerability mirrors the early 20th century global dependence on Chilean natural nitrates before the Haber-Bosch process. Today, the physical layer of advanced computing remains hostage to a single geographic point of failure.